Let's talk about one of the most massive, most powerful galaxies we can see from Earth, Messier 87. You might also know it as Virgo A. It is an absolute monster of a galaxy, a supergiant that basically rules the Virgo cluster. But this behemoth has been hiding a secret identity, and today we are going to uncover it. Okay, let's dive in.
So just to give you an idea of the scale we're talking about, M87 is the gravitational anchor for a supercluster of over 1,000 galaxies. It's a true cosmic titan. Its starry halo just completely dwarfs our own Milky Way. Its gravity is literally shaping its entire neighborhood. But the real story, the really wild stuff, is happening deep down in its core.
I mean, just look at this thing. It's a colossal jet of superheated plasma blasting out from the galaxy's center. And this isn't some little puff of smoke, it's a continuous beam shooting out at relativistic speeds. We're talking near the speed of light, and it stretches for thousands of light years. So the big question is, what kind of engine could possibly power something like this? That's the mystery we're digging into. All right, so our investigation starts with a hunt for that power source. We're on the trail of an engine that can accelerate matter to almost the speed of light, and our very first clue lies right at the heart of M87.
This is the number, 6.5 billion. That's the mass of the object at the very center, in terms of our sun. Imagine 6.5 billion suns all squeezed down into a single point. Yep, it's a supermassive black hole, and it's one of the beefiest we've ever found. Its gravitational pull is just staggering, which makes it our prime suspect for powering that insane jet.
Okay, so we found our engine. But just saying a black hole did it isn't really enough, is it? How does it actually work? To figure that out, we have to zoom in and look at what's happening right around this gravitational monster.
And here's the fuel tank. Any gas, any dust, any unfortunate stars that wander too close get sucked into this swirling, superheated whirlpool called an accretion disk. The friction and the gravity here are so intense that all that matter glows unbelievably bright right before it disappears forever. This disk is what feeds the beast. Now obviously, we can't just fly a spaceship over there and snap a close-up. So what you're seeing here are different scientific models. Think of them as visual hypotheses based on all the data we can collect. Each one represents a different idea for how the jet forms or how the disk is behaving, all trying to match the light and radio waves we detect from 55 million light-years away. And this brings us to another puzzle. It's not enough to just say the disk is hot. How is it getting so energized? The physics going on in this extreme environment are so complex that even something as basic as why it's glowing is a huge point of debate among scientists. So there are two main competing ideas. The first is shock excitation, which you can think of as massive cosmic sonic booms crashing through the gas and heating it up. The other is photoionization, where crazy intense radiation blasting from the center acts like a giant spotlight, energizing the gas and making it glow. For M87, the evidence suggests both might actually be happening. Photoionization dominates closer in, while the shocks take over a little further out.
Okay, to really solve the mystery of M87's true identity, we need more evidence. We need to look beyond that glowing disk and start following the trail of energy this galaxy is blasting out across the universe.
You see, M87 doesn't just shine in the visible light our eyes can see. No, it's a powerhouse at almost every single wavelength, from low-energy radio waves all the way up to the most energetic gamma rays imaginable. And every part of that spectrum is another clue, a different piece of the puzzle telling us what's really going on in its core. One of the most nagging questions for a long time was about its far infrared light. Now, in most galaxies, that kind of glow just comes from cool dust. But with M87, a lot of scientists suspected something else was up. Was it just a normal, dusty galaxy, or was this glow part of the signature of its powerful engine?
And here's where the science gets really cool. Observations from the Herschel Space Observatory basically settled the debate. Researchers looked at the data and said, nope, there's no evidence of dust here. The light is perfectly explained by something called synchrotron emission. Now, that's just a fancy term for the light that gets shot out by electrons spiraling around magnetic fields at almost the speed of light. Realizing this was a huge aha moment, it was a critical clue.
So let's connect the dots here, because this is crucial. We now have a set of fingerprints. We've got a powerful jet, we know it's kicking out synchrotron radiation across the spectrum, and we know the core periodically erupts in these violent flares of super high-energy gamma rays. When you put all that together, it doesn't sound like a normal galaxy at all. It points to something far, far more extreme.
So with all our evidence collected, it's time to identify the real culprit. There's a very specific type of cosmic object out there that matches this energy profile perfectly.
Meet the Blazar. Blazars are a type of active galactic nucleus, and they are famous for being incredibly bright and for changing brightness really fast. But their single defining feature is that their relativistic jet is aimed almost perfectly at us. It's like we're staring right down the barrel of a cosmic particle cannon, and that orientation makes them look way, way brighter than they otherwise would.
And this, right here, is the smoking gun. This chart shows us the energy coming from M87's core across the whole spectrum. See that distinctive double-humped shape? The first hump is from that synchrotron radiation we keep talking about, the spiraling electrons. The second, higher energy hump? That comes from those same electrons kicking photons up to gamma-ray energies. This exact shape is the classic textbook fingerprint of a blazar. Case closed, right?
Well, we have the motive, that supermassive black hole. We have the fingerprints, the jet, the flares, that telltale energy signature. It's time. Time to deliver the final verdict on M87's secret identity.
The energy profile is a dead ringer for a blazar. But wait a second, there's a catch. By definition, a blazar's jet is supposed to be pointed right at us, right at Earth. But we know from really detailed observations that M87's jet is tilted. We're seeing it from the side, at an angle of somewhere between 15 and 25 degrees. So how can it be a blazar?
And here's the beautiful solution to the whole mystery. M87 has all the physics of a blazar. It's got the engine, it's got the fuel, it's accelerating particles like crazy, but we're just seeing it from an off-axis angle. It's a blazar that's been misaligned. And just like that, the puzzle is solved and its true identity is revealed.
So why does this matter so much? Well, first off, it means we have one of the universe's most powerful particle accelerators right in our cosmic backyard. It's an incredible laboratory for studying extreme physics. Second, because we're not being blinded by the full force of the jet, we can actually study the area around it, the disk, where the jet launches from, in amazing detail. And finally, it's this brilliant confirmation of the unified model for active galaxies, which basically says that a lot of different-looking active galaxies are actually the same thing, just viewed from different angles.
You know, the fact that M87 is a misaligned blazar just goes to show you that even the most famous, most well-studied things in the sky can still hold these profound secrets. It really makes you wonder, if a giant this close to home could hide its true nature for so long, what other incredible cosmic revelations are just out there, waiting for us to look at them from a slightly different angle?